Hello everyone, welcome. So in last video we were looking at the conditional probability mass function, and this is what we have seen as a definition of this conditional probability mass function when we have more than or when we have multiple random variables. Alright, let's proceed further. So if you look at this definition of this conditional probability mass function in case of multiple random variable, let's suppose if I bring this denominator term to the left hand side, what we will get is the version of multiplication rule. So if we bring this denominator to left hand side, we will be having here probability that random variable x takes the value little x, at the same time y takes the value little y. That will be equal to, let's say, first random variable y has taken value, so I am just assuming, so probability that random variable y has taken some value little y times, once this y has taken some little value, what will be the probability that x will take the random variable x will take the value little x, and this will be the conditional probability, right? And this is nothing but the multiplication rule, right? If you recall, when we were talking these things in terms of the event, now we are talking in terms of the multiple random variable, that is it. So what is this? So this is the probability that random variable x takes a value little x and y takes a value little y is equal to the product that the probability that random variable y takes a particular value y times the conditional probability that x takes on a particular value little x, given that y take on a particular value little y. You can think like this also. So you have to find the probability that random variable x takes a, and one more thing, I just want to recall you, when I say that random variable takes a certain value, so in your mind you should have the picture that it is equivalent to saying that some event has occurred, right? If you have already seen my random variable lectures, then if I am saying that some random variable has taken some value, then in back of your mind you should map this to equivalent of saying that some event has occurred, right? So if I am saying that what will probability that random variable x takes a value little x and at the same time y takes a value little y, that means I am talking about happening of two events simultaneously and probability of that. So that is equal to, let's say that this random variable y has taken some value y, so that means I am assuming that some event has occurred first, and that is equivalent to saying that y has taken some value little x. And once this event has occurred, so under this condition or under this evidence or under this given event that has happened, what will be the probability that random variable x will take the value little x. I hope this is clear, and I should not too much emphasize here because we have already talked in very detailed manner that how we see these things in terms of the event. So let's proceed further. So here I have assumed that this first, that random variable y has taken some value little y. This may also happen that y we will be assuming it may happen also that so equivalent expression we can say for this joint probability that random variable x and y takes a value little x and at the same time random variable y takes a little y. Let's say first random variable x takes a value little x. So once this event has happened, then I am talking about the conditional probability. Since this x has taken some value or this event has occurred, then I am talking about what this random value under this condition, what this random variable y will take the value little y. And point to note here is that I am writing all these things in terms of the PMF notation. If you are not still clear as of now using this PMF notation, how you can see this in terms of the probability directly. So this is what I am writing, that probability that random variable x takes the value little x and y takes the value little y, that is equal to, let's say that first y is taking some value, so or equivalently saying that this y is taking some value, that this event has occurred first, so probability that y has taken some value little y. So once this has occurred, then we will have the next, that given this y has taken some value little y, what will be the probability that random variable x will take some value little x. So this is equivalent to this one. So what I have written here is in terms of the PMF notation, right? And you must be comfortable at this time in the PMF notation, because I have used so many times that you should be comfortable at this time. So these two expressions are kind of similar. It depends on which event has occurred first, and the expression will have that notation accordingly as per whatever the event has occurred first, right? So this is the multiplication rule, or you can say the version of the multiplication rule. So far we were talking about just two random variable. We can talk about in general more than two random variable. Let's take more than two random variable. So let's look at a specific notation, so or expression. So let's say if you have given this probability, conditional probability mass function. So here we have three random variables. So by looking at this probability mass function, you may probably guess that what it has been asked or what it is saying, right? So here we have given this condition, or we have given this evidence. Under this evidence we have been asked about the probability of this random variable x that is taking the value little x, right? So if we have to write this, what we are asking is that probability that event, or in terms of the, if I have to say in terms of the random variable, so that random variable y is taking some little value little y, sorry, random variable y is taking some little value, random variable y is taking some little value y, and at that same time given, it is also given that random variable z is taking some little value z. Then it is asking that what will be the probability that random variable x will take the value little x. So this is what it has been asked. So you can again use the definition of conditional probability. So that will be equal to the probability that all the event happen. So probability that random variable x takes the value little x at the same time, or we can use the comma also instead of n or comma, both are the same thing. Random variable y takes the value little y, and at the same time random variable z takes the value little z. Probability of that event divided by the conditioning probability. So in this case the conditioning probability is this joint probability. So probability that random variable takes the value little y, and at the same time random variable takes the value little z. If we have to write the same thing in terms of the PMF notation, we can write like, so this is the probability of happening all these three events. So in terms of the joint probability mass function, we are talking about the three random variable x comma y comma z. Random variable x takes the value little x, random variable y takes the value little y, and random variable z takes the value little z, divided by the probability mass function of these two events where we are talking about the random variable y and z, and we are finding the probability that random variable y takes the value little y, and at the same time random variable z takes the value little z. Alright, so if we have multiple random variable, I think we would be comfortable now with the expression and with the notation. We will do problem, do not worry, we will do multiple problems once we are done with this conditional PMF. I will bring a lot of problems. Also, once we are done with this chapter, I will be attaching the practice problem on our app, or you can directly access through the mindspaneducation.com. So we have the separate video on that, you can just look at, and how to access the practice problem for each chapter, right? For the probability or for the linear algebra and calculus will be upcoming, so you can go through those video. And yeah, I think that is all in this video. Thank you.